architect and a certified passive house consultant with Passive Depositive. We are sustainability and building science consultants dedicated to decarbonizing the built environment. We work with architects, developers, homeowners, contractors, institutions, really anyone who is responsible for a building, whether new or existing, to help them meet their environmental goals. So we work primarily along the East Coast, but we do have some projects throughout the rest of the country. So this presentation, I wanted to look at the steps to take towards high performance design and construction, passive house, and I guess ultimately decarbonization of the built environment. So first, I guess an attempt to start to answer the question of like why design a passive house. And I'll get to the energy savings and all the positive outcomes for individual buildings. But the underlying imperative here is that buildings are responsible for about 40% of annual global CO2 emissions. And we are anticipating massive growth over the coming decades on the order of trillions of square feet. And despite that growth, existing buildings are going to continue to be a majority of our building stock in the coming years. So we have a whole lot of new buildings, a whole lot of existing buildings using a whole lot of energy. And on top of that, some of the latest analysis and reports from the UN highlight, just how little time we have in order to avoid the worst climate outcomes. It's kind of shocking, but we're talking like 5 years to take significant action, like cutting emissions in half. So because buildings are such a huge slice of the energy pie, they also have this opportunity to be a huge part of the climate solution. And the good part is we have strategies available now. And so that's what I want to review here in this presentation. And I'm looking at 7 steps towards passive house. And I included a step 0, so I cheated a little bit. So I guess it's 8 steps, but these are numbered 1 through 7 or 0 through 7, but there really isn't an order of operation per se. All of these are important. All of them support each other in multiple ways. And they all need to be thought about from the beginning of the project in order to realize a holistic design. So if the goal is decarbonization, then I felt like I needed to throw in step 0, which is dealing with embodied carbon. And I know that Michael Hindle, the co-founder of Passive Depositive, also has a presentation in this climate tech event. And I know, I'm pretty sure he goes into embodied carbon in more depth. So I'll just give an overview and encourage you to check out his talk. But really quickly, we generally categorize buildings' carbon footprint into 2 types, embodied and operational. And if we look at the life cycle of a typical building, carbon emissions are happening every step along the way, from raw material extraction and construction to use, maintenance, and then finally the end of life. A majority of embodied carbon is associated with the front end of this cycle, so materials and products. And high embodied materials are those that take a lot of energy to extract and install. And some of the worst offenders can be seen on the right side of the screen. That's concrete, masonry, steel, refrigerants, foams, glass. On the other end of the spectrum, on the left side, we have a lot of options available for low embodied or even carbon smart materials that can store carbon. These are generally biogenic plant-based materials that draw down carbon as the plant grows, and then hold that carbon in the body of the plant as they're turned into building products and store it for the life of the building. These are things like straw, cellulose, hemp, cork, wool-derived insulation, wood framing, and there's a whole lot more. And there's some really just amazing potential here with carbon storage, the ability, allowing buildings to act as a long-term drawdown strategy. Reduction strategies for embodied carbon are pretty straightforward. We want to use less material and we want to use better materials from a carbon standpoint. But obviously, I'm not suggesting we don't use glass. I know there's a place for concrete, even foam and metals, refrigerants. So we want to be strategic about when and how we need to use these high embodied materials. There's so much more to talk about with embodied carbon, but I'm going to move into the steps here and just and start out by defining passive house. So it is a performance-based design standard that prioritizes occupant health and comfort, building durability, and significant energy reduction. In fact, we can see up to like 90% decreases in energy use sometimes. these two graphics that you see are essentially showing the same thing, that, how passive house design can kind of crunch those energy loads to a fraction of what we'd expect from typical construction. This, again, makes net zero or even energy positive buildings so much more attainable. So here are steps 1 through 5, and these are the basic principles of passive house. We have mindful design, so that's right sizing and positioning for optimum solar orientation. We have high performance, airtight, and well insulated envelope. In the middle there, we have using high performance windows and doors to minimize heat losses. So these first three are passive design based conservation measures. After which we look at active mechanical systems, which can generally, they're in passive house design, mechanical systems are smaller, less expensive, and much less complex. If we're thinking about this in terms of construction costs, we're essentially juggling the money around a little bit. We're taking it out of those large, complex mechanical systems that generally have to be replaced every 20 or so years anyway. And we're putting it into a robust building envelope, which should last the life of the building. So step 1 here, diving into the principles, paying close attention to building context. So that is solar orientation. What's the building's relationship to the sun? Site context, where are we located? Is it a city with a lot of adjacent buildings? Are we out in the open? Are there trees nearby? And do they shade throughout the year? Some of the building design concepts to think about here are building massing and how efficient it is. Generally, simpler, more compact forms will limit the amount of exposed envelope surface area and make it easier to hit your efficiency goals. We want to limit corners, cantilevers, other little ins and outs of the exterior assembly. These design elements are more expensive generally to construct and usually more prone to failure. Window placement, not only in terms of the total window to wall ratio, but also actual placement within each facade, and are we balancing, southern shading with solar gain and daylighting and heat loss on the north side. So again, I have these steps numbered, but this is sort of an ever-evolving and iterative design process. And generally, siting of the building and conceptual massing does come along earlier in the architectural design process. But we need to remember that decisions made for siting here in step 1 will impact future decisions. And we can either put constraints on the design, or we can open up new opportunities for a balanced, holistic approach. All right, step 2, this is the envelope, and this encompasses 3 different design concepts: airtightness, thermal insulation, and thermal bridges. So this is all about understanding how the exterior envelope assemblies are performing. That's the walls, the roof, floor, slab. And their role really is to be the intermediary between the outside and the inside. So they control the flow of things like bulk water, air, water vapor, heat, sound, pests. We want to make, as this relates to air, we want to make buildings as airtight as possible. Some of the benefits for this approach include increased air quality and occupant health. So we're limiting just free ingress of pollutants. Instead, all incoming air, including possible pollutants, go through a controlled and filtered ventilation system. Energy savings, so we want to reduce escaping conditioned air and reduce incoming unconditioned air. And durability, so reducing the movement of water vapor into and through the assembly, which can lead to all kinds of problems. The pictures on the screen here are simple but powerful diagramming exercises that we do on all of our projects to ensure continuous airtight layers wrapping around the entire building. Basically, we draw a line around the building, right? And if you need to pick up your pen at any point, then we know we need to look at that spot for how to connect the air barrier components. Okay, the next control layer when we're thinking about envelopes is thermal insulation, controlling the movement of heat, which is critical for keeping the temperature differential from outside to inside. Just like airtightness, we want to make sure that every part of the envelope has sufficient insulation. And passive house buildings, I guess, have a bit of a reputation for super insulated assemblies. And I think in general, this is true. though there is a point at which you can optimize. And I did do a talk co-hosting with Carrie Beer, showing some case studies. And some of those we were able to optimize the envelope on larger multifamily buildings. So check that out if you want to see more on that. Okay, insulation is also used to limit thermal bridging, which is uncontrolled heat flow through the assembly. And this is usually due to insufficient thermal protection, especially of conductive materials like metals or masonry. This can lead to a lot of problems like uncomfortable pockets in the building that are significantly cooler or warmer. And these pockets then need to be conditioned to get them back to temperature. So that requires more energy. And then cooler surfaces within the assemblies risk creating a condensation problem that can lead to all types of problems, which I do want to highlight a bit, because this thermal bridging, it can seem like maybe a small thing. You know, we're scrutinizing all of the small details here, and it can seem like a lot of work for a small amount of energy loss, but there are, of course, real health and safety issues. So what you see briefly on the screen here are two heat flow models of the same part of the building. The one on the left is sort of before the thermal breaks are applied. In both cases, red is good. Red is above the dew point and maintaining a comfortable condition, right? So what you see on the left, the before condition is the entire cavity is below the dew point and it becomes a massive condensation risk. This is introducing water into the assembly and can lead to what you see below, which is rot and mold, some of which might be hidden in the walls for years. So yeah, thermal bridges lead to wasted energy and can be comfort issues, but there's also obviously a real health risk here. Okay, so the next step here, step 3, is, so I already mentioned the placement of windows in the facade as it relates to the sun. So in step 3 here, we're kind of accepting the reality that windows are pretty much always going to be the weakest part of the envelope, right? They have a lower R value than an insulated wall. So when we talk about glazed assemblies in a passive house, it's almost always triple pane glazing and highly airtight, thermally broken frames. These are really high performing windows, and I guess I'll just say if energy savings is your goal, then windows and doors, this is not the place to try to save money. You're going to need the high performance, and you're going to need to really pay attention to proper installation because that's just as important as the quality of the window. Okay, step 4. And so far, all the steps really have been passive design-based conservation measures. And I would emphasize that those do need to be considered first, and then we can look at high efficiency mechanical systems like what we see on the screen, balanced, efficient ventilation. A passive house building is airtight by design, as we noted, so we need a continuous ventilation system to supply fresh air to occupants. This needs to come through a high efficiency energy recovery ventilation unit that's going to draw out waste heat from the exhaust air in order to preheat that incoming fresh air, meaning the heating system then doesn't need to work quite as hard to get the incoming air back up to temperature. Step 5 is high efficiency MEP systems, and this includes high efficacy lighting like LEDs and appliances, but primarily we're talking about heat pumps and high COP, high efficiency heat pumps for heating and cooling, for water heating, and where possible, if it's the project, using geothermal to even increase that efficiency even more. If mechanical systems are sized and designed with the passive measures in mind that we've been talking about, then they can generally, as I've said before, be smaller, less expensive, less complex. And the degree to which we can use these systems is tied to how well the building envelope is working. Okay, so those are the passive house strategies. And of course, it's more than just houses, and it's more than just new construction. This can really be any building type and new or existing. Okay, the last 2 steps here. And the next step is on-site renewable generation. This is usually in the form of rooftop photovoltaic solar panels. And it's actually usually the place where most people start when thinking about sustainability. And I think that makes sense. It's sort of a visible and obvious symbol of sustainability in our culture. And it is critically important. But again, like mechanical systems, it really should come after the conservation and load reduction measures, because at that point we're consuming less, the solar arrays can be smaller, less expensive, more effective toward the ultimate goal of PV, which is zeroing out operational carbon, operational energy. And the chart here illustrates this. The pink lines are annual energy demand of a baseline building, so not passive house. The blue lines are the energy demand of a passive house throughout the year. And then the orange lines in the middle are the generation of the hypothetical building's solar array. So we can see without the passive measures in place, those pink lines, the PV cannot meet the needs of this building for about half the year, basically over the winter. But with the passive house measures in place, the building consumes less than the solar can produce throughout the entire year. So this is happening even in the deep winter months when we don't have a whole lot of sun. So this is actually a positive energy building all year round with theoretically no utility bill. But the solar array, isn't going to help during a power outage. And this is sort of where our last step comes in, which is resilience. And we begin resilience with the concept of passive survivability, or the ability to float through a power outage while maintaining livable and occupiable conditions. And the goals are unique to each project. What you see on the screen is one of our passive house projects in Washington, D.C., called Weinberg Commons. We modeled a power outage for a week in January on the left and a week in July on the right. During the week in January, the outside temperatures hovered in the teens. And if you can see my mouse, you can see that here. But interior temperatures up here in the green never dropped below 60. And 60, that's not only livable, but it's still pretty comfortable, right, after a week of no power. It's a little bit harder to do this in the heat because you're fighting outside conditions as well as internal heat gains. And especially on this project, which was multifamily, meaning more people, more heat being produced. And so as you can see over here, the outside temperatures ranged between 75 and 95 degrees outside. The interior temperatures sort of steadily climbed to the upper 80s before power was restored. Upper 80s, may not be super comfortable, but it's still livable, especially in an emergency situation. So in both instances, you can see also it took almost no time at all to return to normal power, or to bring this down to back to operating conditions once normal power was restored. Okay, so we modeled a whole week, but that's actually an entire week without power is a rare occurrence. It can happen, but generally you're going to have only a few hours or maybe a day or two at max. And so what we're showing here, in those cases, you might not even notice any temperature shift at all. And that is the goal. Okay, so battery storage is the last step, and we're seeing a lot of options available. This is everything from these small scalable battery systems for individual homes to mid or even large size batteries that can supplement or completely replace a traditional generator. And some of the newest technology that I see is some of these bidirectional electric vehicle chargers that allow either a car or a fleet of vehicles to act as a power source for the building. Some of the benefits that we're looking for with the use of batteries include savings, obviously, on utility bills through demand response. This is the ability to discharge the battery at peak demand hours when there's higher pricing. Possible income sources by selling your surplus energy back to the grid, and this kind of depends on your utility jurisdiction. And of course, as far as resilience is concerned, the ability to use that solar array to charge the batteries during a power outage. And this can basically allow you to run the building indefinitely during an outage of any length, as long as the sun's shining. Okay, I zoomed through that, but thank you, Aaron. Thanks for the opportunity to present on this. There's a lot of benefits to this passive house approach, and I think the good part is we know how to do it, and it's possible as long as everyone on the project team is on board and we're thinking ahead and planning.
Absolutely. Great job, Andrew. Andy, this was awesome. Thank you so much. So I've got a couple of questions. You got a few minutes?
Absolutely, yeah.
Okay, great. So, um, I'm a novice to passive house, but you and Michael and Carrie have been doing it, and others in the area have been doing a great job of educating me and hopefully some of our viewers. And I loved kind of the steps to getting there. Because you hear the term, but I don't often hear it kind of broken down like that. So that was very helpful. I guess one question I have, driving around in the wintertime when there's snow, I'm often confused on this. You have some roofs of homes that are snow covered within a community, and then you have some roofs that don't have any snow on them at all. And I've heard that roofers would drive a community like this, looking for homes like that to figure out which ones needed new roofs. But I forget which one. Is it the one that has the snow covered that has great insulation and the one that doesn't have snow on it has bad insulation? Which one is it, do you know?
Yeah, generally you'll want the snow to stay on there. And if I go back here, I have a picture. Um, where's that thermal bridging slide? There it is.
Yeah.
Okay, so yeah, and this is just frost. This isn't snow, but it would be the same principle. So
Hmm.
you can see those like the ghost lines, the striping effect of this is
Hmm.
essentially you can see the rafters coming through, and
Hmm.
so there's
Hmm.
thermal bridging happening between the where the rafters are, where the wood is, and then in between are the cavities, insulation that's keeping that roof nice and cold. So you want a cold roof essentially. There's a couple different roof types that you could design, but in general, you want to try to keep the snow on there. What you don't want is, in particular, if it's melting, then that probably means you have a lot of heat escaping, so that's not
Hmm.
good. And it
Hmm.
also could lead to water damming, ice
Hmm.
damming, which could be destructive and allow the water to get up and into the assembly. So yeah.
Thank you for clarifying that. I was confused on which one was which. And then I guess another question along those lines is when it comes to solar, like I've seen during the snow, we've had more snow this year than we've had, in years past. So I'm noticing different things that I didn't notice before. Sometimes the snow covers the solar panels, the PV panels. How does that affect the energy that comes with solar panels when there's snow covered, or do you need to melt? Does it need to melt off? How does?
Yeah, that's a good question. Yeah, I mean, if there's snow on it to any depth that's not allowing the sun through, then I would think
Mm,
that it's
okay.
not going to produce either anything or there might be a little bit that's able to get through some of the like the ice crystals there. But yeah, it should. And I think this has a lot to do with like with the slope of how of the
Hmm.
install.
Hmm.
And and the details of that to try to keep
Hmm.
those as clear as possible. I do think that the panels themselves heat up as they're
Okay.
exposed by the sun, so they might tend to melt it a little bit quicker than your adjacent surfaces. But
Hmm.
yeah, that's a great question.
Things driving down the street that I'm always wondering that
Yeah.
I can't wait to ask a professional like you, like, okay, so then let's talk about maybe deep energy retrofits and somebody that wants like I want to retrofit my home. Our home is what 20, 25 years old.
Mhm.
Um, you know, often heard, start with the envelope first, which you definitely explained. But like this winter, our bills were out of control, our energy bills, like most people. I know it wasn't just us, but standing next to the window, I could feel kind of the cold air coming in. The floors are a little cold, so I know that there's a lot of heat escaping and cold air coming in. So I was thinking, maybe we start with a blower door test. Like, we know we want to get windows, or we have the same original windows. I think single pane windows that we had when we purchased the home. We're the second owner here in our house. So where would you recommend an existing homeowner kind of start to figure out a baseline of kind of what comes next in the steps that you've outlined?
Yeah. I think you're absolutely right. A blower door test is a good way to try to not only see how how the whole house is performing, but in some ways pinpoint where some of the worst offenders are. You might
Hmm.
just doing a more general. energy audit, or often called an energy audit, but or just an assessment, you can probably, even without the blower door, start to pinpoint, oh, there's a giant hole in the ceiling to the attic, or there's
Mm-hmm.
you know gaps around the windows that I can see through, or all of
Mm-hmm.
which are conditions that I've had in houses throughout the years. So
Mm-hmm.
it's
Mm-hmm.
certainly not uncommon.
Mm-hmm.
And yeah, the attic, the basement, these are usually areas that less attention is paid to when it comes to various penetrations and openings and holes through the assemblies. So
Right.
yeah, that's a good place to start. I'm talking about Passive House here, and there's kind of two tracks right now, at least through both FIAS and PHI. One is more geared towards new construction, but can be utilized for existing buildings as well. But there's retrofit standards out there as well that kind of walk you through a pretty involved process. I would say like a really good detailed process of how to investigate a building and what to look for, where the risks are. So there are sort of standards and compliance pathways out there for that, but
Mm-hmm.
yeah, trying to do that assessment at first to really understand where the gaps are.
Mm-hmm. Mm-hmm.
And there's always, yeah, with existing buildings, it's hard. There's always a lot of constraints. You can't change the orientation. You sometimes can't get into the wall, or you there's occupants in place, even if it's not your house, or even if it is, and you can't move them. Oh, but you can't put exterior insulation on. There's a lot of constraints there, so it can be really tricky, and it is also pretty specific or pretty unique for each house in a lot of ways.
Yeah, and I would think the disruption as well. I could see why now it all makes sense why Carrie said it took, 5, 6, 7, 8 years to
Yeah.
to do her property, her primary residence that she's done some really amazing things. So yeah, so in the design phase, I'm sure with new construction you can, orientate the home on the envelope, to get the best optimal conditions. But like you said, with existing homes, you kind of you have what you have. So I'm sure some homes are not even homes. Some commercial buildings or just buildings in
Mhm.
general sometimes can be. Is there ever a situation where it's just like not recommended that someone um pursue passive house just because of the way the property is orientated? Or
Yeah, I
is
think,
is every property eligible for this type of retrofit? Existing property.
yeah, no, I mean, I think that it's worth exploring for pretty much every property, but certainly there are situations where it's no matter how you model it or how you come about it, it's just going to be very difficult to make it work.
Hmm.
I would say, unless it's just like it's got to be torn down, like it's that bad of a
Hmm.
property.
Hmm.
I would say
Hmm.
it's probably never not worth it to try to increase the efficiency,
Hmm.
and try to put as
Hmm.
much into it as possible, as long as it's got some, useful life and it can be utilized in that way. But yeah, to hit, I mean, this is a really rigorous standard, Passive House is, and it's one of it's going to be one of the highest standards in the world, really, for energy
Hmm.
efficiency.
Hmm.
And so it's obviously it's not just easy to hit.
Right,
There's
right.
so yeah, I think an existing buildings sort of just make that even harder often.
And then I've heard of architects, engineers, building owners, consultants on properties that have gotten to passive house standards, but haven't gone to the point of getting the actual certification. So it's like so I guess my question is like on a 2,000 square foot home, what ballpark do you know what it cost it to get the actual passive house certification? Like I know with lead, it can be quite expensive, and I think that's why a lot of the certifications, at least from what I'm seeing, some of the design certifications, environmental certifications are more on the high end of the market,
Mm.
servicing more luxury properties, affluent properties, so because they can afford to make these improvements and pay for the certification. Do you have a ballpark of what it costs to get a property certified? Is it 10,000, 20,000, 50,000 to actually get the certification?
Um, it's it's hard to ballpark it, but let me see if I so the certification. So like I usually I'll work through FIAS, which is the Passive House Institute US, and their certification fee might be in the range of I don't know 2,000 or so, and that's
Mhm,
for the like a rigorous QA QC process,
mhm,
both through design and construction.
mhm, mhm,
And then you have a rater involved who would come out to the house to do inspections during construction, do those air
mhm,
blower door tests. And
mhm,
that can be, I don't know, anywhere maybe in the range of, I don't know, 5 to 10,000, maybe a little
mhm,
bit more,
mhm,
depending on the size of the
mhm,
house or the
mhm,
building.
mhm, mhm,
And I'm
mhm,
talking more so like single family houses
mhm,
with these
mhm,
numbers.
mhm,
And then of course, there's like some soft costs involved to have like someone like us at Passive Depositive involved.
mhm, mhm,
Uh, in addition to if you have an architect or engineers,
mhm, mhm,
will be part of that process.
mhm,
Um, and then yeah, there's usually a bit of a premium on the construction side of things, and there's a lot of ways to optimize this and to bring this back in line with typical construction. But
mhm.
again, you're getting a really, really, really good house. So
Yeah.
a 1%, 2% premium is pretty good, I think, for that. So
Yeah, especially if you're focusing on the total cost of ownership as opposed to the,
right,
the first cost.
that's exactly right.
But it,
Yeah.
it does sound like it's a five-figure, kind of mid five-figure investment to be able to get the certification. Now, if you wanted to, you know, design or retrofit to the standard and skip the certification, but if you want the actual badge, there is quite an investment, but to your point, well worth it at the end of the day.
Right,
Um,
yeah, and to get that certification, again, it's like it's an additional like maybe 2 or 3 sets of eyes on everything
yeah,
and just a lot
yeah.
of QA QC, which is really we can design it as best we can. But when we're out there in the field and this contractor who's putting this together, we find that it can fall apart there to no fault of really of anyone's.
Hmm.
It's just hard to do. And so
Hmm. Hmm.
having those folks in the field and at the certification organization who are looking over everyone's shoulder and making sure things are happening is just making sure you're getting what you're paid for.
Yeah, I think that was one of the things that Carrie mentioned before. I think I was asking on our last video,
Mhm.
kind of what the barriers to adoption were. And I think hers was just having the workforce, the contractors that really just understand this methodology is and supply and demand. If you don't have a big roster of a cadre of people that understand how to do this, maybe the contractors are charging a premium. But you
Yeah,
did say
that's right.
that was a challenge. I loved it when you said that, buildings are the problem and they're also the solution. I'm probably the newest tree hugging, granola bar eating environmentalist. I'm kind of new to the game. I'm late. I apologize, everybody, but I'm here.
Welcome.
But it wasn't, until I started doing some research on sea level rise out on the Eastern Shore and how it was affecting
Hmm.
another one of our presenters, Alex and Lisa Green, who own Harriet Tubman Tours. And, their tours were affected by sea level rise. They couldn't go to certain places anymore. And then it started resonating like, hold up, wait, buildings are actually, you started out your presentation with buildings, commercial buildings, homes, are using 50% of the energy that's produced and the construction materials and the amount of greenhouse gases that are emitted are really the major problem. Like, and then as a real estate practitioner, I was like, wow, I'm I sell and lease the problem. And so that's kind of the genesis of why we started Baltimore Climate Tech, was to realize that, to your point, we're also the solution. The innovators, the early adopters, and the others are the solution to making sure that we have a cleaner environment and a healthier planet. But you educated me today. We only got 5 years to get it right.
Yeah. Yeah, it's scary. I mean, that was put out in December of 2024, so we have less than we have 58 months or whatever. But
I could just see the hourglass, the sands of time,
yeah,
just
we can
like
literally see it now. Yeah, I think it's like, well, according to this report, we need to cut 42% by 2030, and
yeah,
then up to 57 by 2035. So it's a
yeah,
lot to do. And yeah, I think I agree with what you're just saying, and that's really the reason why I had to throw in that um, step zero, which is embodied carbon, because and
yeah, yeah.
I'm learning more and more about it every day too, and it's just like it's amazing how important it is and sort of how invisible it has been, but there's so many great people and organizations working on it right now.
Hmm.
A lot of
Hmm.
the attention thus far has been on operational,
Hmm.
and that's important, but when we look at that time frame of 5 years, 10 years maybe, operational is happening. The operational carbon and operational energy is increments over every year, over the life of this building, which could be 100 plus years.
Right,
And so if we only have 5 or 10 years, we can't we can't take credit for all of those emissions that are either emitted or averted, uh,
right.
in the future. So we really have
Hmm.
to think holistically in the whole building life cycle, and it is exciting. Yeah, that I think that buildings could be a huge piece of the solution here. So yeah,
Well, I think that that's another case for, for offsite construction,
mm,
advanced industrialized construction. New homes only account for 1% of annual kind of sales. So we need to do a lot of retrofits, especially here in Baltimore, where we've got more historic architecture than any other city in the country, more than New York and DC combined. So we've got a lot of retrofitting to do here. But I also think there's a case for offsite construction. Are you finding any factories that are building to the passive house standard? I know that there are a few building to the zero energy ready standard, but I'm not familiar with those that are building to the passive house standard. Are you aware of some?
I think that there are. Yeah,
Okay.
certainly. There's. Well, you know, if you're detailing and working hand in hand, and this was one of the barriers I was thinking about also was team execution and just integration of
Mm,
the team.
hmm. Hmm.
And so I think most manufacturers of these panelized systems can build to the standard if
Hmm.
we're all integrated and thinking through it.
Hmm.
I would say, and this kind of combines not only the operational and the offsite panelization, but also the embodied carbon. But there are great manufacturers of like straw, and I showed that in one of the first slides, but like
Hmm.
straw insulated
Hmm.
panels that are built off site, shipped to the
Hmm.
site,
Hmm.
and then tilt up and finished on site, and they are easily made to passive house standards. So not only now are we operationally at zero, but we can the physical walls of the building itself can store more carbon
Hmm.
than they ever give off. So
Hmm.
so it's a pretty amazing and inspiring thing to see.
Well,
Um,
I did see in one of your slides, the Trident Builders project. Big
mhm.
shouts out to Brendan Mikulski with Trident and Blueprint.
Yes.
That was a project with the Smithsonian Institution, but and that was kind of an off-site construction passive house project, and he's got a great video that documents that.
Yeah.
Um, but in our MLS system, our multiple listing service, there is a tab where somebody can search for passive house. I've checked.
Okay.
And we've got the largest MLS in the country, and when I press it, no inventory comes up. And that covers our MLS covers all of, Maryland, Southern Pennsylvania, Delaware, all the way down to Northern North Carolina, Virginia. Are you finding that most of the residential passive house, the single family residential as opposed to multifamily work that you do, is it for existing homeowners, or is it for, a homeowner that wants to build new construction to the ground up? Or are you finding other developers that are putting these properties on the market for sale? Because if I had a buyer that was looking for one, aside from calling you and saying, what do you have? Or what's coming up, there's
Yeah.
no database to find
Mhm.
passive houses that someone could actually buy and move into.
Yeah, I mean, we're finding all of the above. A lot of the single family clients that come to us are, like you described before, they're living in the house and they're looking to stay there and make it something that they really want, that is
Mhm,
great to live in.
mhm,
So in that case, then yeah, I could see that that's not going to make it to the listing.
mhm,
We do have some developer clients, good relationships with them who are building to either passive house or to the zero energy ready home standard.
mhm, mhm,
And mid-size developments, maybe 30 or so
mhm,
houses. And
mhm,
those are exciting. It's exciting to see that acceleration of the single family market, the passive
mhm,
house single family market in those instances.
mhm, mhm,
Um, and then yeah, I think we had one over the past couple years, one client reach out, single family client who was looking to, they were kind of in a, do we stay in this house and make it what we wanted, or do we build new?
Start right.
So I think that's a little more rare, I guess, for us as someone who's looking for a completely new
Mhm,
house.
mhm,
But yeah, certainly. I mean, and Carrie showed some good case studies of that as
mhm,
well. So
mhm,
certainly
mhm.
over the years that we've had that as well. So yeah, it's a
Well,
bit of mix.
it all starts with building awareness and letting people know, and evangelism and advocacy for this type of way of living and building. It's definitely the wave of the future for sure. So Andy, thank you so much for your time. This has been awesome. I really appreciate it, and I'm excited that we got a chance to hear your thought leadership on the topic.
Great. Thank you, Aaron. Yeah, this has been great. I appreciate the chance to be part of it.
Awesome. All right, we'll talk soon.
All right. Bye.
All right, have a good one. Bye bye.